in the last session that you will have either two identical rows, or at the worst case scenario, you will have one of these rows with a different sign than the other row. And this is what's happening. So all I have to do to continue, I will need to get to the reduced echelon form. So simply I can do the following. I can add this row to the second row, so I will have, first of all, 0, 0, and 0. And for these values, I will have, dividing on negative 0.05, I will have 1. Then I will have 0.03 by minus 0.05, and it's equal to 0, which is gonna lead to that I will have 1 minus 3 over 5, which is minus 0.6, if I'm not wrong. 0, 0, and 0. Yes?
واحنا عملنا
ايه؟ لقينا ان انا عندي two rows similar to each other.
Okay.
So I've added the first row to the second row, which canceled it. And this must happen. So I have all these values equal to zeros.
Amen.
Then I will need this number to be positive 1. And this is easy. I will divide the element on minus 0.05. So dividing on minus 0.05, you will end up having 1 and then 3 over 5. Yes?
Okay.
3 over 5, which stands for minus 0.6. Okay, man? Tamam? Okay. Now I have the relation connecting the coordinates of the first vector. I am talking about a 2 by 2 matrix. So U1 will have two coordinates. Yes? U11 and U12, or X and Y, whatever. Okay, I will say that U1 will equal to X, okay, and Y. If you try to expand this equation, you will have that X minus 0.6Y equals 0. Am I right? Which leads to in X equal 0.6 of Y. Yes? Okay, the second, you will move it, so it's going to be by positive.
حركت الإكس.
حركت الإكس حركت الواي, it's similar. Okay, so the next step that I will have, replacing X by this value, so it's going to be 0.6Y, and that's Y. If I multiply by 5, up and down, I will have that the first vector, which is simply 3 and 5, choosing Y equal to positive 5. Okay?
Why did I choose 5?
We have choose 5 or 10 or something.
Any number.
Just any number that you choose. Just to make our life easier. 0.6 is 6 over 10. So it's a 3 over 5. So if you use 5, it will make it look like 3 and 5, which is more testable. Okay? So this is U1, or this is the span or of the main vector generating this span of solution. Am I right? Okay. In a similar manner, I will do similar steps, but these steps will go for, okay, Mr. Rami, go for U2. And U2 stand for the other value of lambda. The other value of lambda, which is 0.92. Start once more doing the same steps. So it's going to be 0.95 minus 0.92. Am I right? So it's going to be 0.95 minus 0.92. So it will be 0.03. This value is 0.03 also. Okay. Just in a second. This is how it is done. 0 and 0. For the second row, you have 0.05. Then you have 0.97 minus 0.92, and this will leave you with 0.05. Am I right? Okay. Remark that these two lines, or these two rows, are almost the same. Am I right? If you divide the first on 1, on 0.03, if you divide the second on 0.05, you will end up having this matrix 1, 1, 0, 1, 1, and 0. Am I right? Multiplying the first by negative and adding on the second row, you will get this form, which is 1, 1, 0, 0, 0, 0. Which means that for you to, if you consider the two components, x and y, you will have that x plus y equal what?
0.
Which means that x equal negative
Y.
over y. So, which means that the second vector can be written as u2, which is minus y and y. So it will stand for negative 1 and positive 1. Am I right?
تمام.
Okay, perfect. Now you have these two eigenvalues, vectors, okay?
Okay.
So what do you think about the B matrix? Why we did all of this? Why we did all of this? We did all of this in order to get the P matrix, which is going to be used to diagonalize the A matrix. So now I can write, please check, I can write here, can I write here? Yes, okay.
Oh.
Yes, okay, perfect. So now I know that A will equal to a matrix which contains the elements 3, 5, negative 1, and the positive 1. And it will be times the diagonal matrix that I spoke with you about, which is a diagonal matrix, but with the principal elements stand before the numbers of the eigenvalues. In my case, the eigenvalues are simply 1 and 0.92. Am I right? And you will have the P minus 1 matrix, which is simply 3, 5, negative 1, positive 1 by minus 1. Because now I have A equal to P times D times P minus 1. Okay? So if I get back to our model, which states that in order to get x for a t plus 1, what you have to do is to use A to the power of t times x at certain time. Am I right? Okay, perfect. So now I can say that xt plus 1 will equal to the A bar t, which is gonna be exactly like 3 minus 1, 5 and positive 1, but this time it's gonna be times 1 to the power of t, 0.92 to the power of t, zeros all around, and then you will have 3 minus 1, 5 and 1. And this is gonna be times the x con, which was x1 node and x2 node, or the x1 at time t and x2 at time t. This is stand for the population of the city, and this is the population of the suburbans. Are you with me?
At the initial starting.
The initial values. Okay, so it's really very simple. Now I can get the values really very easy. As you can see, Monsieur Omar, hello, how are you? Okay, now you can see, it's really very simple. It's interesting. Once you understand all of this, okay? I will talk to you about the slides. It's exactly the same, yeah. Okay, back to our model, once more, back to our model. Okay, the first step, taking advantage of the previous remarks. What were the previous remarks? That if I want to evaluate the eigenvalues, Mr. Rami, I can take advantage that if the sum of the columns of the matrix that you are going to evaluate the eigenvalues for will be collected or summed to a certain number, it's going to be one of your eigenvalues.
Okay.
So this is once more remarking that 0.95, 0.5, it will equal to 1. 0.03, 0.97, it will also equal to 1. So this means that one of your eigenvalues is going to equal to 1. Also, getting the sum of 0.95, 0.97, which is going to get the trace of this matrix, getting the difference between the sum, which is 1.92, minus 1, the first eigenvalue you're running, second will be 0.92. I will regain the main steps in order to get the eigenvalue. So for lambda equal 1, I will start substituting in A minus 1 times IV equal to 0. Now I'm evaluating the first eigenvector. Okay, taking advantage and making the substitutions, 0.05, 0.03, same way here. And after trying to drive this equation down, we will end up having this relation, which stands for 3 and 5. So this is mainly the span of our work. Okay, in a similar manner for 0.92 and same steps, we will end up having the values which are -1 and +1. So now we are in a perfect shape. I believe there is a typo here in the main slides. The main slides that were sent from Lisbon. I've already sent it to you on WhatsApp. Okay, and you will find them on the website, but this is a negative sign. It's just a minor mistake. When we were trying to solve this, it came from here mainly. This number is supposed to be negative value because you are subtracting 1 minus 0.95 minus 1. معايا يا رامي؟ فده هيديفلوب هنا نيجاتيف ساين زي ما انت شايف كان في نيجاتيف ساين. It's already missed in this model. Okay? So this is the correct solution of this problem. For the other side, it remains the same. Okay, so this is mainly the matrix. If you remark, I'm trying to cancel the negative sign in this matrix. Okay, so it's gonna come up to 3, 5, -1 and 1, exactly like we did. Hi, Mr. Rami. This is the matrix that we spoke about. So taking advantage from A, which is 0.95, 0.03, 0.05, 0.97. So it can be written in this manner, taking advantage of the diagonalization. So the next step, if I want to evaluate the model, xt equal at times x naught, all I have to do is to make a direct substitution as we did exactly for the formulation. Okay. Now, Mr. Omar, I want to get the inverse of this matrix. How to get the inverse of this matrix? ازاي اقدر اجيب الانفرس بتاع الماتريكس؟ طبعا انت انت وحش. ليه بقى؟ لان حضرتك تقدر تستخدم جاوس جوردن in order to evaluate the inverse. وتقدر تستخدم الكوفاكتور ميثود اوكي؟ او جاوس ميثود عشان تجيب الانفرس. واحنا كمان خدنا ميثود a short cut for a 2 by 2 if you remember. To get the inverse of a 2 by 2, okay, what I have to do. Number 1 to evaluate the determinant. فلذلك هعمل زي ما عمر قال. فاروح داخل اعمل ايه؟ قايل 3 times -1 which is -3 minus 1 times 5. The sum will be -8. صح؟ بعدين اروح قايل 1 over -8. بص كده. بصوا. In order to get the inverse of this matrix. اوكي؟ عشان اجيب الانفرس بتاع الماتريكس دي اول حركه هيبقى 1 over the value of the determinant. الفاليو بتاعت الديترمنت كانت بايه يا عمر؟ هيديني 3 times 1 which is 3 اوكي؟ اوكي؟ ده 3 times 1 minus vice versa القيم بالعكس فهيدي لك 3 minus of -8 which is gonna be positive 8. طبعا خلي بالك من الساين ديفرنس اللي انا قلت لك عليه التايب بتاع الاشارات. فالمهم انا حسبته بالفعل. سكند ستيب بص بقى هعمل ايه عشان اجيب انفرس لو سمحت. Second step. بصوا يا شباب. I will replace the elements of the principal diagonal. So it's gonna come up to 1 and the mean. And they change the sign of the secondary diagonal. يوم ده هيبقى بكام يا عمر؟ بتهز دماغك انت مش معايا. ده ب1 وده ب-5. يبقى تاني once more. أنا حسبت الفاليو. I will get the determinant value of this matrix, which is simply 3 plus 5, which is gonna come up to 8. هيبقى 1 over 8. بعدين I will replace the elements of the principal diagonal. اللي تحت يبقى فوق اللي فوق يبقى تحت. وهتشينج الساين بتاع السايدز. يبقى ده 1 وده مين؟ -5. معايا؟ بعدين كل element من الاليمنتس دي هيبقى divided by 8. So this is simply the value of the inverse of this matrix. تمام يا مان؟ تعال بقى نتشيك situation بتاعنا if we want to apply it by certain numbers. This is the matrix 4. 1 over 8 لو انا عملت بقى multiplication هيطلع بالريزلت ده. اوكي يا شباب؟ الو؟
ايوه
اللي هو ايوه ايه؟ ده طلع ازاي؟ هتاخدنا على قد دماغي.
عملنا كروس مالتيبيكيشن عملناه.
صح. هضرب دول في بعض.
ايوه.
ازاي بضرب دول في بعض؟ First row, first column. So you will have 3 times 1 to the power of t. بعدين 0. بعدين هتاخد الفيرست رو تضربه في اللي بعديه. هيدي لك النيجاتيف بتاع 0.992 to the power of t. بعدين هتنزل نفس الكلام بالنسبه للسكند رو. فبالتالي هيبدا يظهر عندك الترمز اللي فيها 0.92 to the power of t and so on. بعد ما تعمل multiplication لthese two matrices هروح اعمل لهم multiplication for the inverse. من هنا يبدا يظهر عندك ال 1 over 8 اللي انا واخده بره as a common وتبدا النمبرز تو اد اب بالشكل اللي قدامك. حضرتك معايا؟ اوكي. طيب بص بقى انا عايز اكلمك دلوقتي على النقطه اللي انا كنت بكلم رامي عندها وهو on the long run. الستيدي ستيت اجيبه ازاي؟ steady state it means after a long time how's gonna be the situation movement between these two towns. Okay, all I have to do is to take the limit. This is the graph that we spoke about before they came, and then I will take advantage from the limit as I told you. If you want to read the remarks, he is saying to you in the long run the population distribution converges to a vector, and in and out movements between city and suburbans are finally balanced. So the movement will be balanced down the road. Okay, that's the population distribution doesn't change anymore with time. So if it was going to be 15,000, for example, it will remain like this. If the number of the people in the city decreasing from 30,000 to reach 15,000, it will stay like this, and so on. So if I want to evaluate the situation, how it's gonna be, all I have to do is to take the limit for t tends to what? To infinity. For the value of xt, which is 80, it's supposed to be xt plus 1. I'm talking about the value that's controlled by the time. So actually what's gonna happen, or what's gonna be affected, is the 8 to the power of t. Because it's the only part that contains the variable. The others are constants. So, taking advantage of the limit, I will get what I want. In a specific for our problem, this is the problem, this is the eigenvalue and eigenvectors. I've succeeded in evaluating them. I've ended up having the A matrix. So AT power x is going to come up to this form. This is the form that we are talking about, this one. The second step, if we multiply by x now, which is the column of the initial values. Okay, taking the limit. Okay, taking the limit. Hello, Mr. Osman. If I take the limit, Rami, خليك معايا. لما اخد الليمت ده constant. ده constant value. شايف فيها تي؟ ده فيه تي؟ ده فيه تي؟ مين اللي فيه تي؟ اللي في النص. طيب تي ده باور. t to the power of 1, 2, 3, and 4, it will make this value equal to positive 1. But for fraction, and you are moving the power, it will converge to what? To 0. So once you start taking the limit for this matrix, which is b, d, b minus 1, all of these are constants, you will end up having this form. 1, 0, 0, 0. الماتريكس دي جت منين؟
لا 0.92 بتconverge ل 0 وال1 بتconverge ل 1.
That's exactly right. This is the A matrix. I'm sorry, this is the B matrix. This is the matrix after convergence, after the steady state, t moving to infinity. This is the inverse. Multiplying them all together will leave you with the current situation, which is the population of the city will decrease with time to reach 15,000 instead of 40,000. And the urbans will increase from 10,000 to 25,000 by time.
الموديل ده مش بياخد population growth.
مش بياخد ايه؟
population growth.
بياخد population، هو بيدرس population movements.
ايوه بس ما ينفعش يبقى عندي population movement without population growth.
هيبقى فيه، بس هو حط condition ان the population growth remain the same. You started with 40,000 and it is still 40,000. So you have like a normal distribution, the number of births and the number of the people who are leaving our world, they are already almost the same, so it's a 40,000 and it will remain like this.
عندي مشكلة نفسية بس.
مش مشكلة عدينا يعني. Okay, perfect. Okay. I need now to go through exercises on dynamical systems. I'll make a short stop. And they will continue. Okay? Thank you very much.